Good morning. My name is Kelly Powers, and I was a CS pilot instructor in Massachusetts, and I'm here with Jeff Gray. I'm also the CSTA Greater Boston co-president, and I've been very involved in CS education since 2005.
Hi, I'm Jeff Gray from the Science. I've been teaching CS principles since 2011 as one of the piloters. I'm offering a MOOC this summer with the Google CS for HS. We're also working to train 50 high school teachers throughout Alabama on CS principles through an NSFC 21 grant.
And hopefully you all are teachers here to learn about our experience in teaching CS principles. And what our goals are for this session is that you'll leave with a deep understanding of what CS principles is and how you can possibly implement it at your school. As we know, computing is radically changing the way we play, the way we communicate, the way we educate, the way it's used in the professional sectors, in science, engineering, banking, transportation, travel. Because it's so pervasive in our lives and in society, the demand for computer science skilled workers has increased significantly. And not just in the tech sector, in the banking sector, in finance, in medicine. There are 3 key magazines that have highlighted this issue, that we do not have a skilled workforce, yet the demand for computer science-enabled workers continues to persist, and it's going to grow. So the best jobs and the fastest growing fields include, number 1, a software developer. The 7th is information technology consultant, according to CNN Money. Computer World has many reports indicating that we're going to continue to see growth in job opportunities for IT. It'll increase by 22% by 2020. In 2014, US News ranked the best jobs of today was computer science software developer, number 1. Number 9 was web developer, and I believe number 2 was IT consultant.
I've had a chance to visit with a lot of high school students as they are coming to campus and recruiting them. So we talk a lot about the things that Kelly just mentioned in terms of job opportunities, and in particular the U.S. News and World Report that just came out this past March, we hand out to parents and students as they come to visit. So those are really compelling evidences that you can give not only to the students, but to parents and to your administrators as well. There's a lot of slides that come out that target the Bureau of Labor Statistics, and this is just one that came out that looked at computing as one of the skill sets that would be used throughout all of different STEM majors and dominated many of the STEM occupations. You can look at, if you have a magnifying glasses, you can see the small URL here, but we actually will have these slides available online as well. This slide actually gets me in trouble a lot of times with parents, sometimes when we're describing this, but it shows the amount of job availability in certain areas mapped across degree production in those areas. So you can see in the bright green, this is where the job availability lies, and then in the other marked bars represents the different degrees that are being given in those areas. So things really stand out in terms of where the jobs are and where they're not. And we talk about job availability as a recruiting measure, and also your parents and your students and administrators may also want to know like where the jobs are. So this is a very important thing that they would be concerned in, and this data is available also from the Bureau of Labor Statistics and various NSF and other STEM tracking organizations. There's also a group that tracks job availability, job offers, and starting salaries. I don't have the 2014 numbers, but the 2013 numbers, computer science students coming out of 4-year degrees were averaging just under $65,000 a year. And computer science in the past 3 years, I believe, has been designated as the one major with the most number of job offers. When you're talking to students and parents, you know, having a job and having a well-paying job is something that's obviously attractive to them. So that's some of the kind of things that motivate the need for driving computer science into your schools that may not have been, students or the parents may not have been informed about that.
So we have all this data saying that there's a demand for a skilled workforce in computing. Yet, when we reflect on what's happening in our own school district, can we ask our superintendent, our principal, our guidance counselor. What's happening with computer science education at our school? What answers would we all receive? What is computer science? That's a whole other conversation. What will they say if we ask the guidance counselor or our principal? It's not a one-to-one. So given computers' impact across society, we believe it's important that all students have access to a foundational experience in computing. So as we have all students dissecting frogs, sometimes physically, sometimes virtually, we believe all students should have the opportunity to understand how information flows across our network, how programs are created, how to use their device in their pocket, not just to consume information, but produce information with that device. Participation in computer science has actually decreased, while the other STEM areas has increased. When we think about who's participating in computing today, not only in industry, but in our classes, in computer science classes across the country, you'll learn that underrepresented minorities are not included. They're not represented. Women, African Americans, Hispanics, Native Americans, and persons with disabilities, we make up 70% of the population, and we're not having the opportunity to engage in computer science opportunities in the job market and in our own school system.
I also wanted to highlight one of the things that Kelly just mentioned about the need for counselors understanding what computing is about. So NC-WIT has a great Computing for Counselors program. You can order kits that are available, and they freely send those out, and you can use those to help inform your counselors about what computing is about, in addition to what CS Principles itself may be about. Excuse me. So challenges with the current computer science AP, it's been one of the lowest participating exams, but that's been changing. We'll see in just a moment. Very much a programming-centered course, so the whole course is pretty much centered on learning about Java and how computer science and programming is centered around that, and the specific semantics of Java. And it's very deep, so you go very deep into programming itself, but sometimes you may not touch on topics in computing that CS Principles will cover. So some of the things that we do in CS Principles are not often covered in that's the current CSA exam. So also we found it's a little bit more challenging to train teachers who do not have a computer science background on the CSA exam as the CS Principles. So in our work in Alabama to train CS Principles teachers, we have backgrounds from career tech, business, math, and science. We're finding that a lot easier to train those teachers than we would if they were trying to learn the CSA exam in Java. So from 2005 to 2009, I believe that CS courses taught in high schools across the U.S. were down, and the number of APCS courses was also down, but there's been a lot of bright hope. So this slide will actually be updated on the internet, so this is, has some information that we need to update just from information from last week. So the 2014 AP conference last week announced that computer science A participation was up 26% from last year, and computer science A was I believe, the fastest growing AP exam in terms of participation. And in 2013, there was a 19% increase. So we also have a challenge, as Kelly mentioned earlier, with underrepresented populations, women and others from different backgrounds, and how CS Principles has been designed to be more engaging, much more focused on encouraging and engaging with students. So it's been mentioned by Owen and Fran earlier about other opportunities that are available to learn more about computer science, in particular how K-12 computing over the past year and a half has really taken off. So for those of us who've been doing this for decades, there's been a lot of knocking on doors and not getting response from teachers and administrators at times. And now I'm finding administrators who would not be interested in talking with us in the past are now coming to us wanting to engage their teachers in our professional development. So the past year has been really exciting from that perspective. So the new AP CS Principles effort, the Exploring Computer Science effort, Other things about recently, the past year, so many states now adopting computer science as a math, science, or other elective, counting towards graduation. The whole effort that Code.org has initiated has been a great shot in the arm in terms of raising awareness in the hour of code, and all the different new curriculums being developed across K-5 through 8 and all the way through high school as well.
So that was the pre-overview. So now I want to give you the session overview. So I put myself in your shoes. If I was a teacher coming to this conference, what do I want to walk away with? And we want to share our experience with you in teaching this pilot. So there are 3 things that I would like to walk away with. I want to deeply understand what is CS Principles. If I want to implement this course back at my school, what do I need to know today or to get started? What's unique about AP CS Principles? It's another AP. This is a lot of conversation on campus. We already have an AP course that we don't teach called APCS. What is unique about APCS Principles? And the third takeaway as a teacher, okay, Kelly Powers, you just gave me all this information. Help, what do I do? We want to emphasize that there are so many rich resources that can help you get started, and they are across the country. So it's up to you to try to take advantage of some of the PD online, work with your CSTA chapters to bring professional development to your location, and explore what's on the CS Principles website to see what works for your style of teaching and what resources work for you. But the resources are rich. They've been tested by more than 50 pilot teachers across the country. So you'll be equipped to really start exploring how you're going to implement this course back at your school. That is our hope. So you already learned that there's been plenty of piloting of the CS Principles course across the country. I've been part of the last pilot, Pilot 4, where we involved 40 high schools and 10 universities. There are other organizations also performing pilots that might not be even included in this specific count, this official count. On csprinciples.org, there's a nice map that with little dots showing all across the country where schools have started to implement this pilot program. This is an older slide, so you can get an update on the website. So what is CS Principles? It has core characteristics, and I am purposefully repeating some of the information that has been already expressed to you this morning, because I want you, again, to leave with a deep understanding. So the CS Principles has this framework, and for me as a teacher, what is this framework? So it's 7 ideas, and then it's a practices, computational practices. 7 ideas, and then computational practices. So there's coverage of 7 ideas, which Fran has highlighted, and I'll get to them in the next slide again. But what's kind of unique about this course is the way we assess students. Students are assessed through a performance task. And I looked at that as like a portfolio of their work that they have been kind of developing over time. But it's actually one task after we have built up their skills in computational thinking and use of computational practice throughout my course to prepare them for this amazing task. This course involves a lot of collaborative work, collaborative teamwork, individual reflection, and lots of writing. And at first, as a computer science teacher, the most writing my kids have done is comments in their codes. So I was like, what is this writing all about? So what are some of the practices? Collaboration, communication, analyzing their work, abstraction, create, and create some more. Connection. So computational practice woven throughout the course. And this nice big bullet below, this is one that I continue to say to myself. We give you big ideas. Each idea has an enduring understanding. After coverage of an idea, or multiple ideas in a lesson, what do I want my students to persist with after my course ends? What do I want them to leave this experience with? What are those enduring understandings? What are the objectives that I'm trying to cover in this particular unit or across many big ideas? Essential knowledge statements. What must my student know in order to be successful in achieving this objective? Now, I spent time with you all with this language because I had a lot of trouble with it. And as soon as I was able to grasp this, then I felt like I was a better teacher for my students. I've got a big idea. What's the enduring understanding? What are some of the objectives I'm trying to cover? And what must my kids know in order for me to achieve that objective with them? So I'm going to just drill down into two big ideas right now with you, and then we'll flip through the other 5 ideas in general. So when I look at this big idea called creativity, and the idea of creativity and computing are prominent forces in innovation. They allow us to explore and create. At the end of the study of this big idea, students will use tools of computing to create interesting artifacts that are enhanced by computational practices, that are enhanced because they collaborated with students in our classroom, that are enhanced because they're able to connect different ideas of things that are happening with technology in society and and new creation in our classroom. An enduring understanding. Computing enables people to use creative development processes as a creative expression or to solve a problem. So when kids leave, we're not just using computing to solve mathematical problems. I use computing to create an app that I can now share with my family, that I can possibly use to study history or remember science facts. So that's the enduring understanding. It's not all for programmers or a specific person in society. I can do this. I can create. Some of my learning objectives, I can create a computational artifact. I can creatively express myself using a computer. What must a student know to be successful in this task? They need to know what an artifact is. What is an artifact? With the aid of a computer, I can create an image with the aid of a computer and express myself, and perhaps even solve a problem. I can create a program, a video, a web page. And again, these practices are woven throughout the course. I can collaborate with my colleague, my peer in the classroom to help me analyze my artifact. Perhaps I can improve my artifact, connect it to something that already exists. I'm sorry, there's a question from the audience?
Barrett would like to know, Barrett would like to know if your slides are posted anywhere.
Yes, I believe our slides are posted, and at the end of the session, I'll be able to let the audience know exactly where they're posted. So the question is, are the slides posted? And they are publicly posted. By the end of the talk, we'll give you the exact link. I'm going to spend another minute drilling down on abstraction. Abstraction is an abstract concept. It's kind of difficult to teach kids abstraction. It's a process, a strategy to reduce detail, to focus on concepts that are relevant to understanding and solving problems. By the end of this study of abstraction, students will learn to work with multiple levels of abstraction. They'll use models, simulations. They'll simplify complex topics in a graphical form, textual form, and tabular form. They'll be able to understand how data is changing. They'll be able to identify how to identify patterns and recognize what an abstraction is, as well as create an abstraction. By the end of the study, what do I want them to leave with? What should they persist with? Multiple levels of abstraction are used to write programs and creating computational artifacts. My goal is for them to develop an abstraction. That's the objective, creating a computational artifact. Before they're able to create this abstraction, what is the essential knowledge statement? The process of developing an abstraction involves removing detail. And again, the practices, computational practices include collaboration, communication, analyzing with peers so that they can actually create an abstraction. And then quickly, I'll fly through the 5 big ideas that I haven't drilled down on. Data. Computing enables methods of processing information across all disciplines. So what's really unique about this course, we pull in data sets that interest kids. One of the sets that we examined was on cyberbullying, was on tweeting patterns, was on baby names. So we're using data sets that we can give to students to process with the use of a computer to then form new knowledge. Algorithms, another big idea. Algorithms are the foundation for expressing a computational solution and fundamental to everyday tasks. Students have the opportunity to develop algorithms. Programming. Programming is a big idea used throughout CS principles, and we can use any language that makes sense for your course. And I happen to use App Inventor, and I adopted something called Mobile CSP, which I'll get into a little bit later. But basically, by introducing this big idea of programming, students learn concepts and techniques related to writing programs, creating programs, debugging programs, and they create artifacts, images, music, visualizations, simulations. They learn about the internet, another big idea. Computing networks support communication and collaboration. Students develop a basic understanding of what's under the hood. How does the internet work? They also get a sense of what are some of important impacts of the internet on society, including cybersecurity, identity theft, and what are some of the characteristics of issues with our internet. And then the impact. That's the last big idea that is covered in this section. Computation has changed the way people think, work, live, and play. The methods of communicating, solving problems, collaborating, and doing business have changed due to innovations in computing. Students learn how that can be harmful and how that can be beneficial. On this slide, which is a deck that will be available to you, there's a link to University of Washington video, which are very rich to share with your students. Why study CSP? Why study CS education at all?
So I think we have a question online.
Elizabeth Dillard says that she is sorry big data is going. Maybe the facility speakers can say a thing or two about that.
Well, I have a comment on that, and Kelly can offer some comment perhaps. So I don't think big data is going away. The performance task called Investigate is going away. So the data unit itself is very much intact. In fact, it's a nice kind of segue into the next part of this talk. I'm actually still going to use the activity that I associated with the Investigate performance task as a homework assignment in my class that I teach at the college level. And I think some of the high school teachers we're working with will also do that. So big data for sure is not going away, as I understand. In fact, it's I think a core thing that we're actually at on our MOOC, and so it's very much still intact as far as I can understand. Okay, so one thing I'd like to note about the big ideas, as Kelly was talking about, they're described often separately, but when those are being taught, they're very much integrated and cross-cutting. And so whenever a new topic is being introduced in a class, it's really useful to talk about how that one new idea relates out to the other big ideas. And the previous slide about impact is one that really touches that clearly. I think the Beauty and Joy of Computing also does this, and we try to almost every class go out for 3 to 5 minutes and pull out a current topic or something that's in the news and relate that to the current discussion that day. So there are many places where you can go for information like that. The one that I use the most is called ACM Tech News, and that's, I think, twice a week they send a digest of a dozen or so news stories about technology. And it's always the case, somehow it's coincidental that the stories from ACM Tech News always have a relevance to something I'm discussing in class that day. So that's a way to get impact without treating the big ideas as empty silos. Making those cross-cutting analogies and relationships helps to, I think, bring the whole goal of what we're doing in CS principles into the students' minds. So there's a lot of adaptations of the CSP curriculum, so you can go and look at the CSP curriculum framework, and that's kind of like a specification you could think of, and then there's various implementations of that. So at UC Berkeley, the Beauty and Joy of Computing is a well-known implementation. You can go to bjc.berkeley.edu, and that has several foundations, and one we even use in our work in Alabama. We're using the SNAP language that they have for some of that work. We also are doing a MOOC in Alabama, so there's the URL for that here. We're about halfway through that MOOC, so if you're coming on and interested in that, feel free to join us. We're keeping it open for a while, and we're just ending the programming part, and we're moving into data this next week. So we'll have topics on big data related to the last online question, and we have Michelle Roberts from IUPUI coming on and giving several guest lectures on what I think will be some really interesting ways to teach the data unit. The mobile CSP group has been doing a lot of great, and Fran mentioned earlier the project Lead the Way efforts. STEM-C at Texas. Rich resources there. So you can see a lot of the units and lessons already packaged up and with videos and great links to other resources. There's also efforts at Delaware, the Compass work at UCSD and UMBC. There's a lot of efforts going on. I'm sure I missed a few. I apologize for that, but there's a lot of efforts also from the National Science Foundation, CE21, where these are particular implementations of curriculum. And you know, it wouldn't be too bad to go out and grab the best parts, or you might think of each one and incorporate that into your own. So there's no dictated specific way to teach this, as long as we're following the guides and the curriculum framework. So I'm going to discuss a little bit about the performance tasks, and Kelly will also discuss one. So we'll give you an actual example of student work from 2 of the performance tasks. Actually, the create performance task Kelly will cover. I'll be looking more at what we would do in a data unit. Also, there's the explore, and there's a few typos on the slides, and we're updating those. So if you check back, the slides will be updated in a day or so, I assume. So a lot of the interesting thing about the performance task is the collaboration that can happen. So the students working in teams on the create. They're doing pair programming on an assignment, and they're working individually. They're working together on some reflective report that describes that. Then the explore performance task is done more individually, looking at some of the innovations and impact that computing makes. A lot of times when we're teaching this throughout the year, it's helpful to scaffold some of the lessons. So building up to the performance task and giving the students some ability to understand the foundation they need to be able to do the performance task on their own. So I'm going to enter into a case study of data unit and give you an example of what a homework assignment might look like. And then Kelly will offer some insight into what the create performance task could be in a high school setting. So I think there's an online question that we have.
Yes. Alex Booth says, it would be great if there was a single list of specific activities and resources, software, websites, etc., which pilot teachers have used for teaching each big idea. Does something like that exist?
Well, there is the cs10kcommunity.org site. So that site is kind of a repository of a lot of the efforts, both for CS principals and also ECS. So I believe it's cs10kcommunity.org. Is that the correct URL? So that has some information that's true. So checking that page out will also be a place where we could go and look for a collection of resources, and that's being updated and added to throughout. Another online question?
Yes. This is a posting by Lynn Diaz, who's also here in the room. In addition, I hope, Lynn, if I think I'm reading it correctly. In addition, teachers commented that 3 tasks were overwhelming to administer. The development committee made a decision to reduce the number of performance tasks based on data and evidence provided in the piloting of the tasks. And I hand it over to you guys.
Right, so that was a comment from Lynn, and I can confirm the same thing for just teachers I work with in Alabama, that there were 3 performance tasks, now down to 2, and there was a lot of writing, and both teachers and students were, especially at the end of the year, felt a bit overwhelmed to accomplish all that. I'm sure, Kelly, you have some comments on that too?
Well, I think one of the joys of being part of this pilot was the College Board has been very responsive to the pilot instructors. And you know, when you have over 40 high school teachers and students participating in the pilot, being able to give feedback to the development committee and to Lynn to say, you know, our students, this is kind of, not only is it a shock to me, you know, doing all this writing in a computing class, it was really difficult for our students. So it's been, as I said, very joyous that they're so responsive. So what hasn't been working, they're listening to us as teachers, and that's kind of a new thought in itself, right? Like they're listening to our voices. That was pretty significant that they eliminated one of the performance tasks. So another thank you to Lynn and the development committee for doing that for our kids.
kind of related to that, the challenge that I've always heard was the amount of writing, and teachers were not comfortable with grading the writing, even though there was not a stipulation that you had to grade deeply in English grammar. And then I think the students also appreciate a lot of the reduction in writing. I think there's yet another question online.
Yes. Lynn, did you want me to go ahead and finish up the other part that you wanted to say, or did you want to take the floor on that? Okay. So data is included in the AP-CSP curriculum framework. The former performance task that focused on the students working with the large data sets was piloted, and it proved to be ineffective in acquiring the kinds of evidence that the development committee wanted to see. That's what Lynn wants you to know. We have one more question. Just a second. Here you go. Kathleen Johnson would like to ask you, is there a single list of all the schools with developed curriculum somewhere?
I think the CS10K community would be the best place to do that. On the csprincipal.org site, is there a list of that? Right, so Owen just mentioned that the new APCSprincipal.org website will have a more enumerated list of all those who are offering curriculum and professional development opportunities and other resources for teachers. Okay, so let's move on then to some of the discussion in the slides. So I'm going to give an example activity on the data task or data unit that we did at the university level. Just an example, and it's not, I'm not saying this is the best student submission, but it's just an example. This was a part of the investigate performance task, but I still think that this particular topic is useful to cover throughout the course. So what I have available, anyone who is interested in this can email me, gray@cs.ua.edu. I have all of the past student submissions, and I have approval from those students to release those. So if anyone would like to see 30 so examples each year, I can freely share those, and we'll also be sharing those on our MOOC next year, or next week. So the specific example I'm going to do is a student team that worked on analyzing tornado data throughout the state of Alabama, which is a very important topic to those who live there. So that is an idea where we're taking also students' interests and local kind of regional impacts and tying them to things that would be interesting from the CS Principles framework. So before I move on to that example, I think there's one more online question.
It's more a comment, but it would be great if the presenters could show this. Melissa Fernandez says, the last slide shown in this presentation linked to at least 3 different curricula that have been developed. So that'd be great if you guys could show that up there.
Right, so the ones that are shown here is the BJC website, the MOOC that we're doing right now. It's still live if anyone's interested in that. And I know the mobile CSP is happening right now. It just started I think last Monday. So those are 3 resources that have, and I know there's others. These are just ones that just came to mind that we wanted to highlight here. And if you're on Google Plus and you know of others, please go out and post those as well, so those watching online can see that. Okay, Deepa?
Also, Juliet Christopher mentions what Owen mentioned about the csprinciples.org resources page, which also has some lessons.
Right, yeah, that and then the new APCSprinciples.org will have some of those elaborated also. Any questions from the audience? Okay, so we'll move on. Again, this is just one example of something you might want to do in the data unit as an exercise that can be explored. So there's a few typos on here. And this is actually, what I'm going to show are some of the things, the PowerPoint that students actually use to present their assignment in some cases. They were charged with finding a data set online that had over 1,000 records, and then they had to pose several questions that they wanted to ask and try to find out about the data set, but weren't able to look at just as a manual human intervention in trying to discover the answers. So one of the challenges in finding information and discovering that within a data is a lot of times I found students have a lot of great questions, but they can't find a data source to answer that. So what I've done in class is I often present a large amount of resources on where data sources can be found, and those will then serve as places where students can go to pick out their questions. Doing it the other way around sometimes doesn't work because students have great questions, but they can't find publicly available data sources for that. So they first find data sources and then look at a particular set of questions that they'd like to do. Also, the challenge with finding data sources is having them in an electronically readable format. You'll find a lot of data sources available publicly, but they're in, say, PDF files or some form that's not easily extractable to be able to manipulate as a data analysis task. So finding Excel spreadsheets or CSV files or some other way that can be imported is much more useful. So here are some comments that students were given about forming the questions related to this task. So really good questions are those that can't be ascertained just by looking at them manually as a human. So those really don't address any kind of scale. And when we talk about big data, I don't ever try to imply that looking at 1,000 records in a database is big data. So big data has much more than that, and we discussed that in the class. There's some great papers on that we look at in the class. But something that requires computation in order to discover the result. And good questions also span all of the records in a data source, just not a few or just a few columns. So being able to look at correlations between the data and discover that through some computational means. And being able to properly label the charts. We see a lot of students will submit the artifacts and their analyses and not have things properly labeled or easily readable. So we also give some advising to the students on that. So one particular example of a student, we have about 60 such examples. One particular one that had regional or local impact to where I live was a study of tornadoes. So the National Climatic Data Center has information that's publicly available about all kinds of storms and information. So NOAA had that on their website. So students were given that as an example data source. And so they went out and found that, found large sample sets of data, and we're going to look at different issues or questions related to storms. So the storm data events database had a lot of information about Alabama specific storms and also for any other states that you may be in. So the reason this is directly from the students, so this is why they found this impactful in the actual community that they live. So the idea of knowing how weather affects everyday life for safety reasons, for planning reasons, and having that knowledge is very powerful. They wanted to understand the dynamics of these storms by going out on the internet and analyzing publicly available data sets. These were the questions that my students strove to answer in their looking at this task. So they wanted to know we did this in the fall of 2013, they wanted to know within the past 5 years, what year has been the most dangerous. We actually could predict that fairly well in where we live, specifically in Alabama, because of a really bad tornado that hit. But what other things, what month do tornadoes hit our communities? What are the top 10 counties where tornadoes have affected folks? And really important too, what time of the day do most tornadoes occur? That's really interesting because tornadoes at night are much more devastating in terms of human fatality than during the day. So these are just examples of how impact affects a local community and how those students tied that to the data unit to discover some answers. So this very long URL right here, if you have a magnifying glass, if you get the slides, you can click on that. The students used Excel. One of the somewhat disappointing things I see with the data unit is the use of Excel everywhere. So there's a lot of other opportunities to do data than just looking at spreadsheets, and I'm not sure that my students have done that as well as I would have liked. So some of the different categories that were in that data source that they looked at can be seen here, different things about the magnitude or time and date of that storm. And so this is just a real quick screenshot of what that data looked like. So thousands of rows of information about very specific storms, when those storms occurred, their location, any kind of devastation measure, magnitude from different tornadoes are scored on an EF1, EF5 level, and other kind of things like property damage. So unfortunately, we had a really bad tornado touch our community in April 2011, and we could almost predict this just by our intuition, but we had the most number of, we had 245 people. We actually had 5 university students in my community lose their life during that. So that's, again, how impact really can drive local interest in this course. So this was a graph that showed when tornadoes mostly hit, at least in the southeast, and in particular in Alabama, and we discovered that April, which was kind of intuitive. That's the time where tornadoes hit the most, but we also have a lot occurring at times in December and through the winter months as well. And the location, so folks who lived in Alabama wanted to know where particular storms were hitting. So we looked at countywide data in terms of where these storms were occurring the most. And so these are just, again, answers to the questions that the students posed, put together in some kind of artifact that they then submitted as a homework assignment. It was really interesting to know when do tornadoes mostly hit. This was the one question we did not really have any intuition, and the students found out that most tornadoes in the southeast hit between 1 p.m. and 3 p.m. So that was, again, an example of an activity you might do in the data unit related to the former investigate performance task. Maybe not so much writing as I'm going to do this fall as I did in the past, but again, looking at data sources that are relevant to the teams that are exploring those, and then trying to go through some of the earlier scaffolding techniques and discovering some new information that they found through that homework.
I'm just going to make one more comment about the data unit. I haven't taught Excel to my students since 7th grade. So here I am in high school teaching students Excel in this CS Principles course. And what I found, although like we as, if the audience is primarily been teaching a lot of programming, I haven't really used Excel in my programming class. So to introduce that to my students and see how awful they were at using Excel, it was shocking. But then I thought, this is a great opportunity, because I was recently at a company called Dassault Systems, and the executive got up to our chapter members and said, one of the most important skills we need the workforce to have is deep Excel skills, to be able to use Excel to analyze data. And all of the teachers in the room were like, are you serious? And so I was so thrilled that I am now teaching CS Principles, and I'm actually teaching Excel to my kids. But the power of sort and filter, just having those 2 skills down is incredible. And what the kids can learn, just being able to sort data and filter data, and how they can answer their own questions about a data set with just those 2 very simple skills.
I have one more comment about Excel. In Alabama, we have a very well-known large German auto manufacturer in our backyard, and I've come to know that the way that they plan the assembly of automobiles on their plant is to use a 5,000-row spreadsheet that describes how all of the robot scheduling is to interact. So it's really interesting to see. It really surprised me that they're not using some really fancy tool from Germany. They're using Excel to plan out the robot movement within the assembly line of the factory. I think we have a question online, Deepa.
So we have a comment and a question from the virtual world. Elizabeth Dillard chimes in to say that one of her students analyzed spending actual versus budget for the state of Connecticut. So that's pretty cool. Chris Mayfield asks, how are the ideas and practices of data analysis in CS Principles different from what students would do in a statistics course? They use computers too. What makes this material unique to CS?
I think what stands out, so the question is, what is using the data unit in a CS Principles course, or the data ID coverage of the data idea in CS Principles? How does that differ from what students are doing in a statistics course? what I would say is we're teaching the students to use computing tools to solve problems. So that's our focus. So I can't speak completely to what's happening in the statistics course, but our focus is making the students aware of the power of computing and in collaborating and connecting with one another to use computing tools to solve problems.
And there's various ways you can implement this. So I think beauty and joy of computing, they can use Snap to look at data. You may look at databases, and there may be much more different kind of analyses you could do computationally wise. I think there is a lot of overlap, could be, but I think the variations that we would allow would even have more expression of creativity.
I'm sorry. There's a question in the audience?
A quick question about that last project you just walked through, the norms and trying to get that data. Can you give us an idea of how much class time that took from the student start to finish?
Right. Just to qualify, that was a college class. So that was a college class, and we did all of our equivalent. The question was, what's the difference, or how much time was spent in class on this assignment? And this was a college class for me. And so this was a homework assignment out of class. As the performance tasks and other homeworks were done, this would be much more class time devoted. So I would imagine probably, 3 to 5 days would be a good estimate. That's just my guess at this point. An online question?
Yes. Give me just a second to locate it, please. I'm sorry, I just seem to just trying to find it. Give me a second. I know who it is from. I found a nice product.
Okay, well, maybe we can go ahead and move on, and then Kelly can introduce. Great.
I got it. Juliet Christopher says, I'm about to learn art programming for data analysis. Do you have experience with it or know anyone with experience with it in terms of whether it would be appropriate for high school students to use for the data unit? Good question.
Can you say the first part again? About to use what?
R programming.
Right. So about to use R, or there's some folks in the audience who are also using SAS or other kinds of environments. I think that works if the instructor has a good background. So I know Carrie Arbro here uses SAS in her class and even teaches a whole class at the high school level on SAS. So those teachers who have that background, I think it works well. I think R would also work well if the teacher's comfortable with that. And there's nothing that I understand in the framework that would prohibit that. So I think that's the nice thing about CS principles. There is a standard framework in the curriculum framework, but teachers are allowed to explore that in their own expertise level.
And Chris Mayfield says that these are great tools which are more suited for computer science than Excel. Like tools like R, SQL are much more amenable to teaching CS than Excel. As a community, we have been struggling to get K-12 teachers. This just jumped. When Chris said we are on the bleeding edge, we really are on the bleeding edge. As a community, we have been struggling for years to get K-12 to understand CS, to understand that CS is not the same as Office applications. And now we are teaching Excel in AP-CSP.
Well, I share the same concern when all of my students submitted mainly Excel artifacts. So I actually teach a little bit of SQL. Google has a really nice interface with their Google Doc spreadsheets with GQL. So I actually teach GQL in my college class. I'm not sure if that would be always appropriate in the high school classes, but you can teach SQL inside of a Google Doc spreadsheet and get that concept of queries out to the students.
And again, we want to emphasize that the tool for your class might not be the tool that I would use for my students. And remember, the executive at Dassault was very happy to share with us that kids should know deep Excel skills. So being able to process information and develop knowledge from that information is one of the objectives in studying data. you can achieve those objectives in many ways, using many tools. So I'm going to get ready to go on to the next example. So I'd like to ask my audience, who is kind of staring at me right now and looks like they need some audience participation. Have you ever heard of whack-a-mole? How many of you have heard of whack-a-mole? In a carnival, in an indoor gaming arena. Well, if you don't know what whack-a-mole is, it's basically at a carnival, you pick up a stick and these little moles pop out of a hole and you try to whack them and gain points. And a lot of the kids that I teach know what whack-a-mole is. So I have a lesson that I have adopted from the mobile CSP curriculum. Mobile CSP was created by Professor Ralph Morelli from Trinity College. And in this lesson that I'm about to share with you, it's an extended lesson. So at this time of my year, I'm covering programming, problem solving, creating procedures and variables. And I absolutely love this lesson to teach deep programming concepts to my kids. What is a variable? What is a procedure? And I'm covering so many big ideas in this lesson. We're talking about abstraction, creativity, and programming. So just like any lesson that's part of the curricula that's available to you, the lesson that I have at my disposal already identifies to me as a teacher what are the enduring understandings that this student should leave with. What are the learning objectives? What is the essential knowledge? I don't have to create this from scratch. It exists. And what are the practices? And that is a big win for me as a teacher. I don't have to develop this on my own. So in the lesson, it details how the flow of the lesson. The students are going to work in pairs. They're going to collaborate. They're going to make an enhancement to the existing Whack-A-Mole app that they've created on their Android device. They're encouraged to discuss with their peer, how do we want to make this better? So right now the game is just, I whack this mole and I get some points. So I sit with my peer and I say, hey Jeff, this is what we've got. How do we want to improve on this? So we sit down and we brainstorm and we try to come up with some ways to improve this project. How should we enhance this project? So the student is a guide on the side. So we try to let them troubleshoot their own problems, learn a little bit about debugging using App Inventor. And then at the end of this experience, the students are writing. They're writing a reflection in an online Google site in their portfolio, which is part of the course. Day one, we create an online site where we're always writing reflections in our portfolio about each lesson that we cover. So in the portfolio entry, they write how they have modified the Mole Mash game. What enhancements have they made? And this is a slide just out here showing one of my students actually testing her whack-a-mole game on the tablet. So here again, she's used App Inventor. She's downloaded it to the tablet. She's testing her game. So in order for her to actually make an enhancement, she needs to know some essential knowledge. She has to have gone through a little bit of my curriculum to know how to use App Inventor, how to make the basic game, to define a variable. In this particular project, some of the objectives. The students are using a tool. They're using App Inventor. They're creating an artifact. They're creating an app for their mobile device. They're using programming, creating an abstraction. When my students use blocks to update score, so every time they hit the mole, they're increasing their score by 1, I have them create a procedure. That's an abstraction. My students can relate to that as an abstraction. They just created a procedure. That's powerful to me as a teacher trying to teach, again, deep CS concepts. They can write their own algorithms, develop a correct program, and use math and if-then-else logic in actually the blocks to solve this problem. So some of the enduring understandings, again, I'm repeating myself because one of my goals is you guys are going to leave with a deep understanding of CS principles, multiple levels of abstraction, algorithms. We can write programs to execute our algorithms, and it's a creative process. Some of the computational practices, we worked together, we collaborated, we analyzed our work, we made connections to the Mole Mash game at the carnival and the Mole Mash game on my tablet. We're using problem-solving techniques. So now I want to just go and show you real work from a performance task. So throughout my course, and I've learned this from working with a lot of teachers in Hartford, Connecticut, use their experience to learn how to truly scaffold these tasks. So by the time I say, okay, kids, we have to create this amazing piece of work for the College Board. It's called the Performance Task. They are ready. They've been doing writing throughout the course, responding to prompts, putting them on their Google site, and now I've given them this template that says, okay, this is the task that you have now. The socially aware. Work with a partner. This is a collaborative project. We're getting ready. And you can use a combination of graphics, animation, simulation, location awareness, data persistence, and or texting. As you develop your app, the kids are keeping track of what were some of the hurdles that they've encountered and how did they solve them. After they work collaboratively, they'll actually write an individual reflection and reflect on that collaborative process. How was your partner? Were they helpful? Did you do most of the work? Did your partner do some of the work? Because those are some issues that you'll run into in this particular piece of the performance task. So I know the online community. I'm gonna actually pause because I see the light on for the virtual community. There's a question, Deepa?
Janet Cook says that the Khan Academy JavaScript programming class has a whack-a-mole section. So that's
terrific, terrific. So there are other, the comment was that Khan Academy also has a JavaScript, I guess, tutorial where you can have your students create a whack-a-mole kind of game using JavaScript. Thank you. There's another question.
Alex Booth asks, does the MOOC or some other resource provide the training necessary to analyze data via R, SQL, or Excel? In general, will there be training opportunities or a specific community for teachers to hone their CSP skills and curricula? Good question.
So, do you want to answer that?
So the MOOC that we're doing, coincidentally, we're releasing the data unit within the next week, and there will be a lecture on SQL. I'm not saying that SQL is going to be covered directly in the curriculum framework, but we will cover that. In that part, we don't do R. There will be also a section in our MOOC on pivot tables in Excel. And then Michelle Roberts will come in and talk about a lot of really fun activities for data. So I think this could be one of the best collection of data units that I've seen. So her lectures that she's providing, there's 10 different parts and activities, and about how to use even games and explore different concepts in data. So I know that one's available. I'm sure, I know the Pat Phillips also does a data workshop with code.org and through that was the CSTA also. So that's also available. You know, those were live workshops on the data unit and I think Pat has some resources available. I don't know them off the top of my head, but if you were to Google that and go to the CSTA website, I'm sure you could find some information on the data unit there.
Hi, we have a question in the audience.
Can you define between one the word socially aware?
Socially aware app. Oh, I chose that word. It's really related to the curricula that I use. So in mobile computing, when creating an app, we have components that we can use to create a socially aware app. So that might mean I can use a block in my app, or I can create an app that responds to text messaging, right? So it's socially aware. So if my friends are texting me, I can create an app that responds to that event. I'm looking around the room to see if anybody else wants to add to that comment. Texting, that's the main component that I'm thinking right now. The Twitter, yeah, there's an API built into App Inventor, and there are components within App Inventor which has web viewers where I can dynamically check on things that are happening, whether it's weather. It might be a Facebook API. I'm not too sure. I haven't explored with that. But good question. Okay. So now what I'd like to do is show you. Before I do that, I'd like to just take a quick time check. Can somebody tell me what time it is? Okay.
You have about 30 minutes.
Yeah. I do want to save some time for questions. So I'm going to take the people in the room. You're going to be able to see an example of an individual performance task. This is by one of my students. Her name is Haley. The people in the virtual community, you won't be able to see my work right now, but please do listen. So I'll ask the organizers here, can I click on a link? A PDF file, is there a sequence of keys? Of course not. I can, yeah. So here's an example of a prompt from the to write her assessment. And I just chose her randomly. I didn't choose her, but this is a 9th grader. They resisted the writing, but I'll say that, but then I wish my kids by the end of this course, and you'll see the way my kids responded in their early journal reflections versus developed program and how it relates to artist expressions. You can draw and create artwork. It's helpful because the app allows you to save and retrieve your artwork in order to share it. This is one of her biggest challenges, being able to save her artwork. She's using an app. She's letting her user choose colors and draw on a canvas and save it. So that was a big challenge for her. Next question. How does your individual program relate to the collaborative program? How is it different? My individual program is more complex than my collaborative program. And my individual program uses a TinyDB. And she would say that, you know, with such pride. Tiny database. Unlike my collaborative project, which mostly used lists and did not save to a database. The two apps also have different purposes. My collaborative project's purpose was to help the user organize and plan, while my individual app is just for the user to have fun and create. I think I was really successful because she got the idea, the big idea. She created. And not only did she create, she's making the experience for her users of her app experience the joy of creating. The apps are only similar in the way that they both use the label component. My collaborative project used multiple lists. The third question, hardware and operating system on which you develop the program. The language I use to write my app's code is App Inventor Blocks program. The version of App Inventor I use is MIT's App Inventor. And to test my app, I use a Nexus tablet with the MIT AI2 companion. A user can easily interact with artist expression. The user begins by first opening the app. I'm going to skip down, and for those of you who are here, you can see this is her app. The user picks a color and then can begin to draw on the canvas. She has some buttons that erase, clear, save, and she can retrieve old pictures from her database and continue to work. But what I really liked, here's a screenshot of some of her blocks. They look a lot like Snap and Scratch, is from MIT's lab, App Inventor. It's built on the same foundation as Scratch. But I want to come down to question number 8, which I thought was really interesting. My program demonstrates the appropriateness and effectiveness of my chosen language and programming environment very well. The App Inventor programming block language allowed me to code my app so it is effective and interactive with the user. The blocks allow me to manage the complexity of my program by being able to define values and be able to call them. It cut down the amount of code and made it simpler to visualize when programming. The language App Inventor allowed me to call actions and was helpful in organizing items and components. Being able to move the block in whichever order I wanted helped me organize my thoughts. Using the blocks like ifs and thens are crucial blocks that made programming straightforward. So let me see if there's a problem I encountered when coding my app was after the user made their image. They could draw and easily create images, but saving was difficult. The picture of the canvas saved to the TinyDB and the file name that attached to it. After the picture saved, my intention was for the user to be able to retrieve their recent pictures to edit and add to them. I was not able to display options of drawings, file names for the user to choose from. I was going to make a list of the drawing file names, and a new file name would be added to the list each time a drawing was saved to the TinyDB. I discovered this error by looking at my blocks. I also saw the problem when I tested my app. I was not able to fix this error, but it could be fixed by changing some of the blocks in my program. I could have added a list or a new screen that displays the files. So to me, this really reflects what I would want my student to leave with the experience of a CS Principles course. 9th grader, she's able to express herself, she used creativity, she collaborated, she got some key concepts of computing abstraction, making variables, defining procedures, using lists, and most importantly, the ability to use computing to create. And it's not only for the boys in the class or for the nerds in the school. She was able to do this. I'll jump real quickly to Fantasy Congress. We had 2 teams of boys work together. One worked on the mobile app front end for the create task, and the other worked on the web-based end, and they interacted. So I want to just jump down to the user interface because it's really interesting. And for those of you who like fantasy football, they created Fantasy Congress. And this was a collaborative project. The name of our app is Fantasy Congress. Our app is an educational game that helps U.S. history students learn about the U.S. Congress and the Senate. Our app is sort of like fantasy football or basketball, but uses congressmen instead. Our app would be used by U.S. history teachers who would have their students play our game. Our app would be used by any group of people interested in the U.S. Congress and Senate. Our app is unlike any others in that it's a completely unique idea. It combines the thrill and multiplayer fun of fantasy sports with the necessary knowledge U.S. history students need to know about the daily lives of congressmen and our senators. In this way, our app is truly a win-win situation. U.S. history teachers know that their students are engaging in education while the students feel like they're playing a game instead of being lectured. So here's I love the visual of their app. They get to actually randomly choose who goes first and pick their senators and congressmen. And they actually they took advantage of the Twitter API. Just read a little bit about his reflection. I'll stop because I can stay up here all day and share student work with you. My main part was the UI. So this was a collaborative project, user interface. Even though the main focus was obviously on the code, we still needed a nice design for our app. I greatly collaborated with Tanuj as we helped each other create the blocks for my team's page, the draft randomizer, the home page, and the Twitter component. Tanuj was like the captain of our team. He was in charge of our entire website, including the actual draft, the point system, and the fusion table that held all of the information about the draftees. Calvin and Andrew helped out with the Twitter component. Andrew actually collected all the Twitter names for each of the congressmen and senators. That's a lot of Twitter names. Calvin helped greatly with our Twitter feed, and he even tried to set up an auto retweeting system for our app. Unfortunately, the only free one was available, could only do about 5 of the 144. So you can see how engaged and invested these students were based on this experience. And that was what my goal to share with you, to see how deeply they were affected by this experience of CS principles. I'm going to stop and throw it back over to Jeff so he can wrap up the lecture.
You use your right arrow key to go to the next.
Okay, so this is just, again, a collection of resources and links that we had some questions from the virtual audience that asked about this. So these will be on the website, and the CS10K community site is a great place to find some links as well. So these are just some shared conclusions, and then we'll pass it off for questions. One point that I would like to make is, in my students at the college level, we saw creativity just soar. And in particular, my college class is predominantly done with students who are math ed majors. So secondary math ed majors, we're training about 30 students a year who will be in future high schools, and we're using that model, pre-service model, to help get computer science principals across our state. And then also working with the teachers throughout Alabama, also saw a lot of examples of creativity, and we'll see talk by Carol Yarborough later on that as well. So creativity soared. The highly collaborative nature of the assignments was really evident, and students who may have not in other classes had the chance to do that, or feeling, understanding these computational practices. Different understandings and the links back to the curriculum framework needs. We saw a lot of, personally, I couldn't cover in a college class, every particular enduring understanding because of the small amount of time that I had throughout the college class. The diverse student body, I once had over 18 different majors across my university take my class, and we're routinely now over 60% female because of recruiting from a lot of the students from education. So sustainability, at least from my perspective, we're working with groups who are in our state helping to teach AP, so we're looking at ways to increase and develop new teacher PD. Kelly, you have some comments?
I think there's tremendous gains for our students in the experiences that they leave from this course. But honestly, as a teacher, what I have learned from this course is by having my kids write, I can see how much they didn't know. So it informed my practice. So although I would teach them about a variable and then have to reflect on their Google site, tell me what you think a variable is in your own words, I can read how they described it, and it informed my practice. So I could say, I did a terrible job on that lesson because they didn't leave with what I wanted them to leave with. And then I would change how I taught or reteach that particular concept. So the writing, to me, I love it now. I'm so glad I had this experience to be a pilot instructor, because I would never have introduced writing in computer science. And it's just, again, so informative to my practice, and it makes me a better teacher.
I think we now can go back to questions from either the local audience or those who are online. I don't know, Deepa, you see any more activity or comments online?
I guess I don't need to. There have been several conversations going back and forth. The apps that you have mentioned, do you have links for them? That's what one of the questions are. Can we access the apps through a URL or a Google store? And I was just trying to look through your slides to see what apps they were referring to, but I'm assuming you know what they're talking about.
The slide deck that we have that is going to be available to everyone has links to specific student work of mine. They're just the 2 pieces of work. You have on the slide before you Jeff's contact information and my contact information. And if you'd like to see some more work, we'd be happy to share that with you.
Great, and that was from Scott.
We have a question in the audience.
time that you spent on going through the written pieces that the students collect? And how many students is time is that?
Good question. So in my school, computer science is required, which is kind of great for me. So in ninth grade, our students had a choice. They could choose Intro to Java using Eclipse and writing pure Java code with the IDE, or they could have chosen the pilot CS principles. I had 3 sections of CS principles, each with about 26 students in. So I think we covered between 60 and 70 kids, and it was diverse. It was a nice mixture of boys and girls. But those were students who purposely chose CS principles because they did not want to program in Java. So in terms of time, writing happens every day. So once I was able to get their Google site, work with them to go through how do you create a Google site portfolio, and it's just a one class kind of session, they add daily reflections. So we call them do nows. My do now might be, before it's like pre-teaching, I'd get a sense of where do you stand on this concept of abstraction. What is abstraction? And I'd have them actually record just a journal entry. And then we'll perhaps the next day come back and say, well, what is abstraction today? It might have changed since yesterday. So every day they're writing. In terms of assessing?
In terms of for you, the formative assessment of those writing pieces.
Okay, so the question has to do with the formative assessment of writing pieces. So the formative assessment, as the students are writing at that moment, I'm walking the room. So I'll give them maybe 3 minutes to write a response. So it's not something I add. In addition, I'm glad you brought that up. In the as students complete lessons, there are interactive formative assessments that the students get input from immediately. So these little Quizlets where kids actually drag blocks to see if they know how to create a solution to a problem quickly, really short problems. And that informs me as to whether or not they were successful in achieving the objectives of that lesson.
I'm personally intrigued by sort of the writing aspect of it, and on a large-scale assessment for the exam, how easy it's going to be to gauge the understanding versus the writing skills. And so one thing I'd be curious from the great thing about it in the classroom is that you have a lot more experience with the students. And so I'd be curious to get a sense if you felt like the product they produced and what you would look at that and gauge their understanding, did that match sort of, during that poll, did that match your sort of broader view of what the students accomplished and understood? Does that make sense?
Say that one more time, please.
Well, so I mean, when we teach our own classes, we very often have a good sense of the students' understanding going into an assessment, going into a test. And there's a sense of does what they did on paper match what we think they understand based on other things. And so I'm curious, did you feel that when you assessed the students based on that written format, did it sort of match? Or I worry about the student who really understands it but just is a bad writer, and that not showing up.
I can address. Okay, so the question has to do with, did the writing reflect what we thought the ability of that student was in mastering some of the objectives of this course? And that's a great point that was raised, because initially in the beginning of the course, absolutely not. Because the students we didn't develop their writing at all to respond to a prompt. So I'd have one student who was a phenomenal programmer. He would create these amazing apps, and he hated to write. And he was really frustrated, and he would just write in bullets. Like, what's an abstraction? A piece of code that makes my life easier. Oh. So, so that was a challenge. And with some of the computational practices, we're building community in my classroom. So I wasn't going to fight that battle day one with that student, because I wanted him to love what he was doing. So over the course of time, it took a little while, and he would not have written as much as what I've showed you all. But I didn't know his ability was strong. But his ability to, when the College Board gets something like that, they'll be getting snapshots of his code and a write-up of his code. And hopefully by that time, I've got a whole year to develop that writing in a format for a lab kind of course.
One comment I'd like to make, and if Lynn or the development committee can correct me if I'm wrong, the rewriting of the performance tasks that are just coming out, the writing is much more focused with prompts and somewhat reduced, and I think it's less likely for students to not understand what they're supposed to say and help you assess whether they're hitting those understandings that you'd like them to have. So the writing is much more driven by prompts that are in the performance task.
Can I go ahead and take the mic?
Sure, we have a question from the virtual community.
Bruce Schwartz would like to know how much time was allocated to the PTs that Kelly is describing?
Good question. I would say that all of my class was done all of my work was done in the classroom. I didn't get any homework. And I also had the advantage of being a pilot, so I had a lot of that AP stress that wasn't part of, my world yet. So I would say we spent about, 10 class periods, and my class period is 45 minutes. And this is, again, a final project. So by then, we're ready to really focus and respond to these prompts and develop and create an artifact. So 10 class periods. In addition, Ralph Morelli, Professor Morelli's curriculum, he has a day-by-day plan that you can examine and see if that works for you. So you can, shorten things up or add more time on. And the College Board doesn't say I have to use 10 class periods at this time. I mean, I just have to submit to them when the performance task is ready. We have a question or comment from the audience. Andy?
In terms of the guidelines for time for the performance task, I believe that the revised teacher recommendation guidelines will give teachers recommended number of hours.
Okay.
To implement the performance task in their classroom.
So the revised comment from the audience, from one of the members of the development team for CS principals, he had just made us aware that there are going to be published guidelines as to how much time teachers should use on the performance task. Thank you. We have another question in the back.
Is there a violation of
The question is there a compilation of prompts that teachers can look at today in preparation for the AP CS Principles course? And I'm going to push that question. I mean, I have access to the CS pilot prompts, which are actually prompts. So my answer is yes, but I want to just go out to the audience and ask my friend Andy if that's indeed true, if he was paying attention.
So, you mean possibly
Performance task, yes. Yeah.
I believe that the new draft of the performance task will have prompts listed.
Okay. Because I was given a set of prompts to give to my students, so according to what Andy has just said, the prompts will be updated and available.
I'm going to pass it over to Rich and Frank.
Actually, I'm going to have better. Yes.
So the official comment from the College Board was that the prompts for the performance task will be compiled and hopefully available later this month online, apcsprinciples.org.
So we have a question online, Deepa?
In general, a lot of comments on how important and what a good way of teaching them that writing is needed in life and workplace. There seems to be a lot of desire to see the slides and try out the various applications. Definitely a request for a lot of trainings, curriculum being posted, lesson plans being posted, several comments in that direction.
Yeah, so again, the CS10kcommunity.org site has things. In our project, all of our Alabama teachers created lesson plans. So in our project, it's all teacher-driven. So our teachers have out on the CS10kcommunity.org site lesson plans for all of the learning objectives. So that's a resource, and the various other PD efforts are publishing those things online. So the challenge, I think, is some of this material is still kind of gunshot and spread out in different places. So as I understand, the apcsprinciples.org news site will also help to collect all that and provide the linkages out.
And I would add one more comment, and that is both Jeff and I, we have used, Jeff has created his own, he has his own MOOC, which is teaching a pilot of CS Principles. I've adopted Professor Morelli's from Trinity College, and I just want to put a plug in for a MOOC that I'm part of right now for CS4HS. It's happening right now, and what's really cool about it is that it's being run by St. Scholastica, and you can enter as what we call a scout and not really pay attention or jump in and see how much you want to participate in the course. You could be an explorer, which is a higher level of participation. You can be a scholar and earn graduate credit. So you're welcome to ask me after the session or email me, and I can give you some information about the CS4HS online course. And I actually love this particular course, but it's all about mobile apps. So if that interests you, let me know. And also, I want to put a plug in for Dan Garcia is in the room with us, and I've used lots of his materials from The Beauty and Joy of Computing. And what's nice about CS Principles, if you're not comfortable as a teacher using a particular, like I didn't like the way Professor Morelli addressed data because I just wasn't comfortable with it, I could jump over to The Beauty and Joy of Computing and say, how are they teaching data in their version of CS Principles? And that might work better for me. Or I might jump over to Jeff's, or I might jump over to Beth Simon in Florida. So there's a lot of great resources if you're not happy completely with one of the ones you might start off with.
You have a question in the audience?
Yeah, I get the impression you're teaching it for 4 years in high school, and I'm wondering if you think it's possible to do it in a semester with like 45 minutes last year.
In Alabama, we have several of our teachers doing it in a block system. We even have one teacher who has done CS Principles in an 11-week intense period in high school. But that's a magnet school with different levels of achieving students, but we have some who are doing it in just one semester.
And I would try to remember some of the philosophy of this course, where we're broadening participation and increasing access. And I really want the kids to, have an amazing experience in this course. I could not deliver it in a semester and achieve some of the goals of the course. Absolutely not. I couldn't do it. So full year, it's an AP rigor. Remember, don't forget, it's an AP rigor, and we want the kids to have be proud of their accomplishments at the end of the year. You have another question in the audience?
How can you get some information on those semester implementations? Just because, to me, it seems that having information on those semester implementations would assist if you're interested in integrating it with another course that has a lot of overlap, but maybe not all overlap.
Right. Well, the semester implementations, they're also meeting for longer periods in the day. So they're meeting an hour and 15 minutes, an hour and a half. So those are really more intense class periods. And as part of our project and our MOOC, we are releasing a 36-week pacing guide of what we think should be covered according to how we're teaching it with our teachers. And we're going to make that available very soon also. So our teachers who are doing that in the semester system, we're also producing another pacing guide that they can use that's more condensed.
We have time for one more virtual question, and we have one coming up.
It's more a shout out for you, Kelly. +1 for Kelly for making writing an important part of her class. Writing reflections allows students to process. Writing as speaking is an important real-world skill that our students will need in their professions. And this is by Bruce Schwartz.
So we want to thank all of you for being patient. I mean, as students, we don't really want you all sitting there. We want you participating. So thank you for your patience today and just, listening to all we have to share with you. But we're available during lunch. Don't forget Dan could talk a lot about the beauty and joy of computing. Dan Garcia is in the back. Could you stand for a second, Dan? Just say hi to everyone. And again, the development committee, Fran and Owen, they know what the pilots have been using across the country, so tap into them. And Rich also, I think he's got I'm not sure which one you're using for the pilot, so you can ask Rich what he's doing as well. So thanks again. It's great getting to speak to all of you about our experiences. Thank you.
Thank you.